Okay, Asmol thinks that x add 5 squared is x squared add 25 for all values of x. Is Asmol right? You must show how you get your answer. So the easiest way to answer this is what Asmol has done is he's squared this and he's squared this. But we know that when we see a bracket squared, it actually means you need to times that entire bracket by itself. So we need to write x add 5 times by itself, which is x add 5. To do that, we would do x times x, which is x squared, x times 5, which is 5x, 5 times x, which is another 5x, and 5 times 5, which is 25. We can see that by collecting our like terms, that gives us x squared, add 10x, add 25. So no, he is incorrect. And because they've asked us a question, we need to make sure we answer it. So no, he is incorrect. Okay, question 4. The table shows information about the heights of 60 trees. Jacob drew this frequency polygon for the information in the table. The frequency polygon is not correct. Write down 2 things that are wrong with the frequency polygon. Now, when I teach this frequency polygon, I like to think of something which is a bit silly, but it helps me remember, and we call it Polly the shark. So normally with a frequency polygon, we would see a shape maybe a little bit like this, something like this, maybe that just looks a little bit like this. So you'd have your data and you join it up with straight lines. Now, the reason we call it Polly the shark, well, it's kind of something that's evolved, and it's probably a bit silly, but it helps me to remember that when you're asked to draw a frequency polygon, this is the sort of thing we should be seeing. Now, it might be that your data goes up, comes back down. You might end up with a shark fin with 2 fins, but it helps you visualize that the shape of this graph needs to be straight lines, pointy. And where would you find a shark? Well, you'll find a shark in the middle of the ocean. And that helps you remember that we're going to use the middle of the category. So it might seem really silly, but it just helps me remember, particularly when you're asked also to draw things like histograms or cumulative frequency graphs. There's lots of graphs that you could be asked to draw. So I like to remember that a frequency polygon is Polly the shark. Where is Polly? She's in the middle of the ocean. So the 2 things that are wrong with this graph, first thing is they've joined it up with a curved line. Now we know that Polly the shark, she's got a nice shark fin, if you imagine that fin above the water. So first things first, it should be joined up with straight lines. So I'll write that in the first reason, that the points should be connected with straight lines. The other thing they've done is they've plotted 13 at 4. They've plotted 24 at 8. Now, we don't use the top end of the category. We do for cumulative frequency, but not for frequency polygons, because remember, Polly the shark is in the middle of the ocean. So we should be using 2, we should be using 6. So this first point should be here, between 0 and 4, in the middle of the category. So the second thing that's wrong with this diagram is that they've not used the middle of the category. So reason number 1, should have used straight lines to join it up. Reason number 2, we needed to use the middle of the category, not the highest point. Question 6, ABCDE is a regular pentagon. BCF and EDF are straight lines. Work out the size of angle CFD. Now, if we want the size of angle CFD, that's going around this angle here. So this is the angle that I'm after. I'm just going to label it X so that I know what it is that I want. Now we've got a triangle here. And we've got a pentagon here. Now, because we're looking at angles and I've got a regular pentagon, I need to remember what angles inside a pentagon add up to. So with my regular pentagon, remember that a triangle adds up to 180 degrees, a quadrilateral adds up to 360 degrees, and a pentagon, because it's got 5 sides, adds up to 540. We add 180 every time we add a side. So a 6-sided shape, a hexagon, is 720, and so on. That's the internal angles, okay? So I know that all of these on the inside of the pentagon need to add up to 540, and there are 1, 2, 3, 4, 5 angles because it's a pentagon. So I'm going to do 540 divided into the 5 angles. 5 into 5 goes once, 5 into 4 doesn't go, carry the 4, and 5 into 40 goes 8 times. So I know that each of these is 108. 108, 108, 108, 108, 108. And we must show how we get our answer. So that's fine, 540 divided by 5. And then I know that this angle here would be 72 degrees because angles on a straight line add up to 180. I've not been asked to give reasons for my answer, so I don't need to write that down. But if it said, give reasons for your answer, we'd need to say angles on a straight line add up to 180, but we're okay just to put 72 there. We've done 180, take away 108 to get 72. And now we can look at the triangle. Angles in a triangle add up to 180. So 72 add 72 is 144. And we've got 180 degrees in the triangle. Take away the 144. Now, if there's more on the floor, borrow from next door. 10 take 4 is 6. 7 take 4 is 3. And 1 take 1 is 0. So X is 36 degrees. And that's 3 marks. Question 8. Samina has a round pencil case and a square pencil case. There are 4 blue pens and 3 red pens in the round pencil case. So let's draw it. Round pencil case has got 4 blue, so blue, 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 and 3 red, 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 red. And the square pencil case has got 3 blue and 5 red. 1, 2, 3, 4, 5. Samina takes at random 1 pen out of each pencil case. Complete the probability tree diagram. So we've got this tree diagram here, and we can see that we can either take a blue from the round pencil case and then another blue from the square pencil case, or we can take a blue from the round and then a red from the square, or we can take a red from the round and then a blue from the square, or we can take a red from the round and a red from the square. So those are the 4 different things that can happen. Now, we put the outcomes, the thing that's going to happen on the end of the branch, and we put the probability here on the branch. So the probability of me taking a blue from the round pencil case, this first branch, this is for the round pencil case, the chance of me taking a blue from this round pencil case is 1, 2, 3, 4 out of 7. So 4 out of 7. And the chance of me taking red is 3 out of 7. Now, these branches should always add up to 1. These branches should add to make 1, and these branches should add to make 1, because it's certain, probability is always out of 1, and it's certain that you'll take one of those 2 branches. Now, when we come up here to the square pencil case, the chance of me taking blue, 1, 2, 3 out of 8. And red is 5 out of 8. And doesn't really matter what we take out of the round pencil case, is going to be the same here, isn't it? So 3 out of 8 for blue and 5 out of 8 for red. And that's 2 marks for completing our probability tree diagram. Then it says, work out the probability that the pens Samina takes are both red. So we would like to take a red the first time and a red the second time. So we're going to go down this branch and then this one. Okay, now we times along the branches and then we add them together if we want more than one option. In this case, it's just the one option, just following this pathway all the way down. So we're going to do this times this. So 3 over 7 times 5 over 8. And remember, to times fractions, we just do the numerator times the numerator and the denominator times the denominator. So 3 times 5 is 15 and 7 times 8 is 56. So that would be my answer, 15 over 56. If we wanted the probability that the colours were the same, like blue, blue or red, red, then we would also have to times these, and then we'd add our 2 answers together after. But we've just been asked for red, so that's it, we're done. Now, we could write this out for what it is. So 3m squared r is 3 times m times m times r times 4 times m times m times m, that's m cubed, times r times r times r times r times R, 1, 2, 3, 4, 5, times R, 6. Okay, and then we can look at all the terms and put them together. So 3 times 4 is 12. So we know that we need a 12 at the front. We've then got m times m times m times m times m. So in total, m to the power of 5. And we've got r times r times r times r times r times r times r. So altogether, r to the power of 7. Now, what we've done there is if you just look at the question, 3 times 4 is 12. And we know that when we times, we add the indices. So m squared times m cubed is going to be m to the power of 5 because we're going to do the 2, add the 3. And with the r's, remember when you see an r on its own, it's the same as it having a little 1, although we don't need to put it. And r times r to the power of 6 is going to be r to the power of 7. So that's my final answer. Okay, question 12. The diagram shows a piece of wood in the shape of a cuboid. It's 3 centimetres tall, 20 centimetres wide, and 1.2 metres long. Now, before I even start this question, I'm going to go ahead and make that 120 centimetres, because if this is in centimetres and this is in centimetres, I want all my units to be the same. So I'm just going to make that in centimetres as well. The mass of the piece of wood is 8 kilograms. So the mass is 8 kilograms. The piece of wood will float in seawater if the density of the wood is less than the density of seawater. In a large pool, 1 litre of seawater has a mass of 1,030 grams. Will the piece of wood float in this pool? You must show how you get your answer. Okay, so the triangle that we need to use here, as soon as we're talking about density, we need to remember the triangle, density, mass, volume. So density is mass divided by volume. Okay, now the mass is density times volume. Remember, you cover up the thing you want to know and do the sum that's left behind. Volume is mass divided by density, and density is mass divided by volume. So once you know that triangle, we can work out anything from there. Now, we need to find out the density of the wood. We need to find out the density of the wood to see if it's going to float in water. So the piece of wood will float in seawater if the density of the wood is less than the density of seawater. So density is mass divided by volume. So the mass of the wood is 8 kilograms. Now, notice that with the other one, we've got grams, and we tend to do density as grams per centimetre cubed or kilograms per metres cubed. We tend to stick grams with centimetres cubed and kilograms with metres cubed. So I'm actually going to use 8,000 grams, just because then I've got grams here and I've got grams here, and everything's going to be in centimetres cubed. So that's going to be all good. So 8,000 grams divided by and then we need the volume. So density is mass divided by volume. To get the volume, I need to do 3 times 20 times 120. So 3 times 20 times 120 is 7,200 centimetres cubed. And 8,000 divided by that is 1.1 recurring grams per centimetres cubed. So that's the density. And then in a large pool, a litre of seawater has a mass of 1,030 grams. So a litre is going to be the volume. So we're going to do for the pool, we're going to do the mass, which is 1,030 grams, divided by a litre. Now, 1 litre is 1,000 centimetres cubed. A milliliter is a centimetre cubed. So 1 litre is 1,000 millilitres or 1,000 centimetres cubed. So we're going to do 1,030 divided by 1,000, which is 1.03 grams per centimetres cubed. Now look at the units. Because we've done grams divided by centimetres cubed and grams divided by centimetres cubed, the density is measured in grams per centimetres cubed. And now we can see that the density of the wood is more than the density of the seawater. So no, it will not float. Really important that we're answering their question, as the density of the wood is greater. The number of fish in a lake decreases by X% each year. Given that the number of fish halves in 8 years, work out the value of X. So when something decreases every year, normally, let's say it decreased by 5%, we would do 0.95 times 0.95 times 0.95 to get the multiplier, depending on how many years there were. So normally we do, for example, if it was 8 years, we would say 0.95 to the power of 8. Now, if we do 0.95 to the power of 8, we get 0.66. So that would see you get 66% of the original number. So that would leave you with 66%. Now they're saying after 8 years, we've got half. So we want to see that number go down to 50%. So you could absolutely trial and error this if you wanted to. It wouldn't be the best method. We could say, right, okay, 0.91. Oh, we're getting closer, maybe a little bit bigger, 0.92. 51%, so that's a little bit higher. We could go in between and we could keep trying like that. Now, what we're actually saying is something to the power of 8 needs to equal 0.5. Something to the power of 8 needs to equal 0.5. Now, what's the inverse of doing the power of 8? It would be the 8th root. So to work out what's missing here, we're going to do the 8th root of 0.5. Now, on your calculator, if you want to do a root that isn't 2 or 3, you need to press Shift and then this button here to bring up that box. So we want to do the 8th root of 0.5 to find out what number multiplies and multiplies and multiplies. And we can see that we worked out it was between 91 and 92%. It's 91.7%. Now, that's not quite what the question is asking, because it's so 0.91700, which is 91.7%. Now, if I'm doing 91.7% every year, I need to say how much it's gone down by. It's not asking me what's left, it's saying what's it decreased by. So we're going to do 100 minus that answer. So let's times this by 100 in my calculator to get 91.7% and do 100 minus that answer, and we're left with 8.29959 whatever. So 100 minus my answer is 8.299. It wants it to one decimal place, so my answer would be 8.3%. I love these questions. So this is a bounds question. Now, bounds questions means that the numbers have already been rounded, and what we're going to do is work out the absolute best or the highest case scenario and the lowest case scenario, depending on what those numbers have been rounded from. So it says that A is 6.43 correct to 2 decimal places. So they're essentially saying that they rounded it to the nearest 0.01. That's when we round to 2 decimal places, we're rounding to the nearest 0.01. We half that number, so 0.005 above and 0.005 below is the highest and lowest the number could have been beforehand. So that means that A could have been 6.435 or 6.425. They're my 2 options. With the next one, it's been rounded to the nearest 0.001 because it's correct to 3 decimal places. And if we half that, we get 0.0005 above and 0.0005 below. So for B, let's do it down here, we could have 5.5135 or 5.5145. So 0.005 above and 0.0005 below. So that's the maximum and the minimum that A could have been, and the maximum and the minimum that B could have been. Now it says by considering bounds. Sometimes with this question, it'll ask you to work out the upper bound, in which case we're going to make our answer as big as possible. Sometimes it says find the lower bounds, we make our answer as small as possible. If it says by considering bounds, we've got to do both. So they're saying go as big as you can, go as small as you can, and see if they agree. So first on this side, I'm going to do the upper. I'm going to go as big as I can. And on this side, I'm going to do the lower and go as small as I can. And then I'm going to compare them and see what happens. So we know that V equals the square root of A divided by B. V equals the square root of A divided by B. Now, when we have a fraction and we want to make it as big as we can, I want you to think about a pile of sweets. Here's my pile of sweets. Now, and here's the people that are going to eat them. When we do a division, we're saying, if we want the answer to be as big as possible, if I want as many sweets as possible, then I want to start with loads and loads and loads of sweets. So to make this as big as possible, I want loads of sweets. I want to have the most amount of sweets possible. But I don't want to share it with very many people, because if I have to share it with loads of people, I will get less. If I want to get more, then I need to divide it by less people. So we're going to actually make B as small as possible to make this as big as we can. Same with the lower. If I don't want very many sweets, then I want to start with as few sweets as possible and share them with loads and loads of people. So that's going to get me the lowest answer possible. So in that case, for the upper, V is going to be our biggest A, 6.435, divided by our smallest B, 5.5135, and then square rooted. And for our lower bound, we've got the square root of the smallest A, which is 6.425, divided by the biggest B, 5.5145. I'm going to type both of those in my calculator. So let's do the upper bound first. So square root fraction, 6.435 on the numerator, 5.5135 on the denominator, and that is 1.080340323. Definitely write as many decimal points as you get on the calculator. And for the other one, let's just left arrow go back and change it. And that one is 1.07940269. So we found the biggest that V could be and the smallest that V could be. Now what we need to do is compare them. Now if I round them both to one significant figure, they're both 1. Great, they agree. So we can go better. So let's round them both to 2 decimal places. They both round to 2 significant figures. They both round to 1.1 because the 7 rounds up and the 8 rounds up. If we go one better, this one would be 1.08 to 2 decimal places because the 0 rounds down. And this one would also be 1.08 because the 9 rounds up. If we go more than that, then we're going to end up with 1.080 and 1.0794. So then they're going to be different. Oh, 1.079, sorry. So then they're going to differ. So the most that they agree to, if we take it 1 decimal place at a time, is 1.08 to 2 decimal places and 1.08 to 2 decimal places. So that would be a sensible answer to give because both situations round to that. So my final answer that I'll pop on the answer line is 1.08 because they both agree to 2 decimal places. Okay, make M the subject of the formula. Now this is more difficult because the M is appearing twice. So we've got M here and we've got M here. Now my class or students I've taught, I normally get to do a dotted line. You can just visualize that dotted line. What you do to one side, you do to the other. So first thing I want to do is get rid of this fraction. Fractions are a bit annoying to me. There's nothing I can do here. So we're going to multiply both sides by 5 add M, and that will get rid of the fraction. If I times this side by 5 add M, then I've got to times this side by 5 add M. And that leaves me with F multiplied by 5 add M. Notice I've just used a bracket to times by more than one thing, equals 4 minus 3M. So I've times this side by 5 add M to get rid of the fraction, and I've times this side by 5 add M as well. I'm then just going to expand that bracket out. So I've got 5F add FM equals 4 minus 3M. Now, when you're making M the subject of the formula, you need to get all your M's on the same side. And everything that doesn't have an M needs to go on the other side. So I'm going to add 3M to both sides so that it comes over here. So 5F add 3M add FM equals 4. And then I'm going to take away 5F because that hasn't got an M in it. So I've got 3m add fm equals 4 minus 5f. Now, how are we going to get these m's together? I can't add them because they're not like terms, but there is a way of combining them, and that's to factorise because they both have an m in common. So I'm going to take m outside the bracket, and inside the bracket would be 3 add f, and then what we can do is divide by this bracket. It's m lots of this. If we divide by the bracket, we're left with m equals 4 minus 5f over 3 add f. I've divided both sides by that. M is now the subject of the formula because it's m equals everything else. At the beginning, f was the subject of the formula. And that's it. That's my answer done. Okay, and last but not least, we have question 20, which is functions. Now, functions, basically, if you remember, like function machines, they take an input and they give you an output. So when I say f of x is 2x minus 3, that means whatever we make x, if it was f of 2, for example, we would do 2 lots of 2, take away 3. So this tells you what your input is, and this is what we're going to do. We're going to do 2 lots of whatever that input is, take away 3. Same with g of x, that's a different function. G of x takes the input, whatever x is, whatever we tell you it is going to be, it squares it, and then it adds 2. So first things first, I've been asked to do g of minus 4. So g of minus 4 is saying, use the g function, so I've got 2 different functions here, f and g, use the g function and change your input to be minus 4. So I'm going to say I need to do minus 4 squared and then add 2. Now be really careful because minus 4 squared, if you type that in your calculator, you're going to get it wrong. Remember, minus 4 squared is minus 4 times minus 4, which is positive 16. And then we add 2, so that would be 18 as my answer. There, that would be the output. That's it, done. Okay, just remember that your calculator, if you type minus 4 squared, it's going to do the 4 squared first, and then it makes it minus, which makes it wrong. If you want to do it correct, so if we press that, for example, it's minus 16. If we want it to do it properly, we have to put brackets around it, but we should just know that a negative times a negative is a positive, so that one's 16. Okay, show that g of f of x is 4x squared minus 12x add 11. Now, this is something called a composite function. If you want to do some work on this, just search composite functions on Hegarty. So this means we work from the inside out. We're going to do g of f of x. So if you can see here, it's almost like we're saying we're going to take g and the input is going to be f of x. Can you see that? So g of something is this. So I'm going to take g, which is x squared add 2, and my input here is going to be f of x. So I'm going to change this input here to be 2x minus 3. So I've got 2x minus 3 squared add 2. So I'm saying that this bit here needs to be f of x. So I'm taking g of x and I'm putting f of x into it. So we get this. And if I expand this out, remember when we square a bracket, we write it out twice. So that's 4x squared minus 6x add 9, and we've got to bring down that plus 2, which is 4x squared minus 12x add 11. Done. Okay, last but not least, solve f of g of x equals g of f of x. Well, we've just got g of f of x, so we've got the right-hand side already. And then for the left-hand side, they're saying do f of g of x, so put g of x into f of x. To put this, oh, you can't see it, sorry. To put g of x into f of x, we're going to take this and we're going to put it in here. So it would be 2 lots of this, take away 3. So 2 lots of x squared add 2, take away 3. So on one side, I've put g of x into f, and on the other side, I've put f of x into g. So this side is 2x squared add 4 minus 3 equals 4x squared minus 12x add 11. And 4 take away 3 is 1, so 2x squared add 1 equals 4x squared minus 12x add 11. I then want to subtract 2x squared from both sides and subtract 1 from both sides, and I'm left with 0 equals 2x squared minus 12x add 10, which is a quadratic. To solve this quadratic, I'm actually going to half it because everything is even. And because I've got 0 on the other side, if I divide both sides by 2, I get x squared minus 6x add 5. It's a little bit easier to work with. I'm then going to factorise it because I can spot that this is x minus 1, x minus 5. So my solutions are x equals 1 or x equals 5, because that would make each of those brackets equal 0. That is very much grade 9 question though, so please don't worry too much if that's a little bit tricky to begin with. Certainly because I think probably by this point you won't have seen that at school, but have a look on Hegarty if you want some help with that. That is functions, composite functions, and there's also inverse functions as well.